Hi everyone, this is Dr. G. Ravindranath Reddy, working as Assistant Professor in MLR Institute of Technology, Hyderabad. So in this video, we are going to discuss the concept of curve fitting. In this curve fitting, we are going to fit a straight line and fit a parabola for the given data. We will discuss with some examples here. So first we will take what is curve fitting, what is the use of this curve fitting over the interpolation concept. So here, curve fitting is nothing but finding a process of finding a best curve for the given data. Suppose I have given a data and asked to find out the equation or a best straight line for the given data. For example, if you have taken the points, if you have represented the points on the xy plane, this is x-axis and this is y-axis, and this is the data, this is one point and this is another point and this is another point and this is another point. Suppose this is the data given in the problem. Suppose for this data I want to fit a straight line for this one. So if you join this data, we don't get a straight line here, you will get some curve, but I want a straight line. So this is possible only by neglecting some points, and the here. Suppose if you neglect this this point and this point, we will get one straight line. Or suppose if you neglect these remaining points, if you join these 2 points, you will get another straight line. And if you take these 2 points, you will get another straight line. So like this, by neglecting some points, there is a scope to get a straight lines. But you will get many number of straight lines here. But I want only a straight line, best straight line for the given data. So in order to select a best straight line from the set of straight lines, we have to use the concept of curve fitting. So curve fitting is a process of finding a best curve which is suitable for the given data. So we can find out this equation, the relationship between the dependent variable and independent variable by using this interpolation concept also. So in the interpolation concept we have discussed in the previous videos the interpolation. So in the interpolation concept we have seen how to derive the interpolating polynomial. So interpolating polynomial is also a equation or a relationship between the dependent variable and independent variable. So from this also we are going to get some equations, polynomial equations for the given data here. So whereas I will explain this difference between the curve fitting and interpolation concept is, imagine that this is the data he has given. So by using this interpolation concept, we will get a polynomial curve by joining the points. Each and every point must join here. Okay, but whereas, so if you join these points, we will get a straight line. So we will get some curve. Suppose if there are number of observations is equal to 5, then by using this interpolation concept, we will get a polynomial of order of degree 4. So suppose I want to get a straight line here of a linear straight of the form y is equal to a plus bx. Then by using this interpolation concept for the given data, it is not possible to get the straight line for this one. We will get, by using interpolation concept, if you find out the polynomial by using the different methods, you will get a relation y is equal to in terms of x of degree 4, because whenever we are having 5 observations in the interpolation concept, we will get a polynomial of degree n minus 1, but it is not equal to this form. So here suppose it is not possible to get any parabola second degree curve here. Based on this condition, you will get a polynomial of degree n minus 1. So it depends upon the number of observations. But whereas by using the concept of interpolation, we will get a curve of straight line. So this is, if you join this is the curve you will get by using the concept of interpolation. Now, so this is from point A to point B, this is one curve, and point B to point C, this is another curve, and this is another curve, and this is another curve. So each and every point, the curve is passing each and every point here. So by using this interpolation, this interpolation concept is used to estimate the value of y at x is equal to given value at some value of x. So this is only used to find out the particular value of y at the particular value given particular value of x. But whereas in the curve fitting, we will get a entire single curve here, single curve between the given range. Our range is from this point to and this point. So in order to get a single curve between the given range, then we have to go to the concept of curve fitting. So this curve fitting gives here, by using this curve fitting, we can analyze the trend of the given data. Suppose if you take a real-time example, I have taken the temperature of each day. So this is Monday, and this is Tuesday, and this is Thursday, Friday, Saturday. Imagine that these are the temperatures I have taken. And now if you want to study the trend of the temperature during this week, then it is possible only by using this curve fitting concept only. So whether this is decreasing or increasing or anything, if you want to analyze the data, if you want to capture the trend in the data, then we have to assign by a single function. So by using this single function, entire this range across this first point to last point, we have to get a single function only. So once if you get a single function, then it is useful to analyze the data or useful to identify the trend of the data. So that is the difference between the interpolation concept and curve fitting here. If this interpolation concept is used to get the data or to get the value of y between these points or between these points or between these 2 points or between these 2 points. But here we are analyzing the data from the first point to initial point. Entire data we are analyzing the data here from the across the total range from A to E. From A to E, total in between all the points we are analyzing the data. We are identifying the trend in the data by assigning with a single function. So here it is not possible to analyze the trend of the data using the concept of interpolation. So this is the main difference between interpolation and curve fitting here. So now we have different methods for the fitting of a curve here. So that we have graphical method. The first one is and the method of group averages and the method of movements and the method of least squares. So in our syllabus or now we are going to concentrate only on this method of least squares, and by using that method of least squares, how to fit a straight line for the given data, how to fit a second degree polynomial or a parabola, how to fit an exponential curve, how to fit a power curve for the given data. These are the points we are going to discuss here by using the concept of method of least squares. So now fitting of a simple curve using the least square. So we have a linear curve, that is a straight line y is equal to a plus bx. This is a linear curve, and we are going to discuss a quadratic curve polynomial, that is y is equal to a plus bx plus cx square. This is a second degree polynomial, and we are going to study how to fit a power curve by using the concept of least squares, and finally we are going to discuss how to fit an exponential curve for the given data by using the concept of interpolation. So these are the 4 curves we are going to discuss in the curve fitting here. Now first we will concentrate on how to fit a straight line for the given data by using the concept of least squares. Now I will consider this equation of a straight line as y is equal to a plus bx. So let it be, this is the linear curve, that is which represents the straight line. So now I want to apply the method of least squares here, and now by using that method of least squares, I will find out these unknown parameters values a and b, and after finding that a value, b value, if you substitute that a value, b value in equation 1, then I will get a straight line for the given data here. Now we will see how to find out that a and b values here. So in order to find out these 2 unknown parameters, I want to take the help of these normal equations which are given by the least square, method of least squares. So these are the normal equations here. Summation y is equal to n. Here n is represents the number of observations. N represents the number of observations here. So they will give the data. In that data, count the number of observations given and count that number is represented with small n. Summation y is equal to na plus b into summation x, and summation x into y is equal to a into summation x plus b into summation x square. These are the two normal equations you will use to find out two unknowns. So in order to find out these two unknown values, the minimum number of equations must be 2. So that's why we have considered these two equations, which we call it as a normal equations for the straight line. Now solve these normal equations to get the values of a and b, and after finding that a value, b value, you substitute that a value, b value in equation 1. Then we can get our straight line for the given data here. Now let us take one example for the fitting of a straight line. So this is the data he has given, and I want to apply the method of least squares and find the straight line best fit for the following data. So first you count the number of observations given in the table. This is 1, 2, 3, 4, 5. So number of observations which is represented with small n. So that small n value is equal to 5. Now in the problem he asked to find out the straight line. Just now in the previous slide we have taken the straight line equation, that is y is equal to a plus bx. That is the straight line equation. Now in order to find out this a value, b value, we want two normal equations. These are the two normal equations we got. And now what we have to do is, we have to find out the summation of y. Summation of y is nothing but we have to add all the y values which are given in the data, and summation x is nothing but the sum of all the x values in the given data, and then you find out this summation xy values, summation x square values, and if you substitute these values in this equation, we will get two equations. Solve the two equations, we will get our required a value, b value here. Now this is the data. So whatever the x values he has given, I have taken that x values. If we add all these x values, we got that summation is equal to sum of all the values of x is 15, and take this in the second column, take the values of y. So these are the values he has given in the table. In the problem itself, you take that and add that values. So that is sum of all the values of y is represented with summation y. And now in the second normal equation we are having summation xy. So in order to find out that summation xy, first we will take the x into y values. We will multiply these two values here and write down that values under the xy column here. So these are the values of xy. By multiplying its corresponding value of x and y, we got this, and add this, we will get summation xy is equal to 748. By adding all these values, we get this summation xy values. And in the second normal equation, in the last term, we are having summation x square. So for this purpose, I want to have taken this x square column here, and already we know the values of x. Apply the squaring on these x values, we will get the values of x square for each corresponding value of x. Now add all these values here, you will get our summation x square values here. So like this, you find out summation x values, summation y, summation x into y, summation x square. So we can find all these summation x, summation y, summation xy, summation x square. We can find all these things in the normal equation what we have taken in the previous. So here summation y, summation x, summation xy, summation x square. Now whatever the values we got, you replace that values here. So after replacing that values, these are the equations we have seen. Summation y. So whatever the values we got, so for the summation y, you replace that equation 1. In place of summation y, you replace with this value, that is 204 plus. So that is 204 plus n is equal to n into a. N is nothing but the number of observations he has given. that is 5a plus summation x, that is 15b. Next one, summation x into y. Summation x into y is nothing but 748 is equal to a into summation x, that is 15a plus summation x square. Summation x square is 55. Summation x square is 55b. Now solve these two equations and get the values of a and b. A is equal to, b is equal to. So if you solve these equations, you will get a value is equal to 0 and b is equal to 13.6. Now after getting this a value, b value, substitute this a values of a and b in the equation 1. We get y is equal to 13.6 into x. So this is our straight line equation for the given data here. So like this is the best straight line for the given data. Other than this, we don't get any best straight line for the given data here. So y is equal to 13.6 into x. You keep this as it is here. This is our required straight line equation for the given data. Okay. So next we will go for the next curve, that is second degree polynomial, or we can call it as a parabola. So now how to fit a second degree polynomial for the given data by using the least square approximation method or method of least squares. So for this second degree polynomial, this I have taken this is the standard second degree polynomial. So y is equal to a plus bx plus c x square. Let it be, you consider this one as equation 1. Now once if you observe this equation 1, we are having three unknown parameters a, b, c. So in order to find out these three parameters, a value, b value and c value, we want minimum 3 equations here. So we will get these 3 equations as a normal equations. So the normal equations, we will consider these normal equations, 3 normal equations. So these are the 3 normal equations, summation y. This is our first equation, normal. So na plus b into summation x plus b in c into summation x square. Now you multiply this, for this normal equation you multiply with x on both sides, you will get this one. Summation x into y is equal to, neglect this, a into summation x plus b into, already here we are having x, if you multiply this x with x, we will get x square x cube. So similarly you go for this third equation. So now these are the 3 normal equations we will consider to fit a parabola or to fit a second degree polynomial. So by using these 3 normal equations, we are going to get the values of a, b and c here. So once after taking these normal equations, you solve these normal equations as usual as we followed in the straight line. You will get the values of a, b and c. You substitute these values in the equation 1, we will get our required second degree polynomial or a parabola curve. So this is the procedure to find out the second degree polynomial or parabola for the given data using the method of least squares. Now let us take one example for this also. So fit a second degree polynomial or second degree parabola to the following data. So this is the data has given, and for this data we have to find out the best second degree parabola for the following data. Okay, as usual we have considered this is the standard equation, or this is the standard equation for the second degree polynomial or second degree parabola. So y is equal to a plus bx plus c x square. You consider this one as equation 1. And already we have seen the normal equations for fitting a parabola. So these are the normal equations we are having. Already we have seen in the previous slide. So these are the standard normal equations for fitting a parabola or for fitting a second degree polynomial. Now what we have to do is, we have to find out summation y, summation x square, summation xy, summation x square, x cube, x power 4 and summation x square y. So once if you get these summation values, if you substitute that values in these normal equations, then if you solve that 3 normal equations, then we can find out 3 unknown parameters a, b and c values here. Now for this we will construct a table to get these summation values here. So this is our table here. X for each and everything you construct this table as we have constructed here. So X values already given in the data, you take that X values and find out the sum of all the X values. And similarly in the second column take the values of Y and add all the values of Y, you will get our summation Y value. Summation Y is nothing but sum of all the values of Y. And similarly now we got X and Y, you multiply these two values, X value and Y value, corresponding values of X and Y, we will get XY values and find out all the XY values and add that values, we will get summation X into Y. So summation X into Y is, we got that value is equal to 243. And similarly we want X square. So already we got X values, so apply the square and square of these X values, we will get X square values and get the values summation X square. And similarly you get summation, you find out that summation X cube, X power 4, and as usual X square. You multiply this X square column with Y, you will get X square Y column. You find all the sum, add all the values of X square Y and we will get this summation. So like this you construct the table and find out all the summation values which are necessary or which are used in the normal equations. Now we got these normal equations now one by one. Now in the normal equations we are having n. In the first normal equation we are having n. N represents the number of observations. So you count that observations here. This is 1, 2, 3, 4, 5. So number of observations given in the data is 5. So take n is equal to 5. Now substitute all these values in the above normal equations here. So you will get these normal equations. Now we know how to solve these normal equations, 3 equations here, to find out 3 unknowns, or we can use the calculators and we can find out this. So by solving these equations you will get the value of A is equal to 1.42 and B is equal to 0.26 and C is equal to 2.221. Okay, so now we got 3 unknown values A, B and C. Now you substitute these A, B, C values in the equation 1. Then we can get our required second degree polynomial. So this is the best second degree polynomial for this given data here. So this is the way how we can find out the unique best fit for the fit curve for the given data. Fitting a straight line, fitting a parabola by using the concept of method of least squares. So now here in this video we have seen how to fit a straight line and how to fit a parabola for the given data. In the next video we are going to see how to fit an exponential curve and the power curve for the given data here. So thank you all of you for watching this.